So we're going to look at two examples of isotopes here. We've got carbon that exists in a few different forms, and it tends to be written with a certain number after it here. You can see the 12 represents the mass number of one of the isotopes of carbon. So this is carbon as you would find it on the periodic table. One of the isotopes is shown with a mass number of 13, one is shown with a mass number of 14, and they're written like this. So if we try and think about what's different about the isotopes of carbon, let's work out how many protons, neutrons and electrons are in each of these. So in the carbon 12 isotope you have 6 protons, the neutrons is 12 take away 6, which is 6 again, and the number of electrons as always balances the number of protons. 6 positive protons, so 6 negative electrons. With carbon 13, we've still got a proton number or an atomic number of 6. We've still got 6 electrons to balance it. But this time, 13 take away 6, there are 7 neutrons. Carbon 14, 6 and 6 again, but this time there are 8 neutrons. So of the 3 isotopes of carbon, they all behave in a similar way chemically. They all have 6 electrons, so they all have 4 electrons in their outer shell, but they've got slightly different masses. Here we've got chlorine, another example. Now, chlorine appears on your periodic table with 17 as its atomic number and 35.5 as its atomic mass. And that's because there's actually a mixture of the 2 isotopes of chlorine that exist, and on the atomic table they've taken an average number between the 2 masses of chlorine. There's a lot more of the 35 isotope, so that's why the number is closer to 35 and isn't actually 36, which is halfway between the 2. Okay, so if we look at chlorine, we've got protons, neutrons, electrons, 17 protons, 17 electrons and 18 neutrons in this one. That's 35 take away 17 is 18. For chlorine 37, the number of protons is still 17, the number of electrons is still 17, but this time 37 take away 17 tells us that there are 20 neutrons in the chlorine 37 isotope. So chlorine 37 is a heavier isotope. Now the question they'd love to ask you in an exam is what is an isotope? And using the numbers we just wrote down of the number of protons, neutrons and electrons, that will help us to explain what an isotope is. So isotopes are things with the same number of protons, the same number of electrons, but they have a different number of neutrons. There you go, that's isotopes.